All right, now, what I'm going to do in this video is I'm going to make use of function notation here and work with you on again, understanding and making sense of function notation. But what we're building up to is making sure we can understand it enough to evaluate an expression like here at the very bottom of this chart, okay? So see at the very bottom, we've got this expression we've got to be able to evaluate. That's going to be really important, okay? And so what I want to do is let's start, get it back to normal, by looking at doing function notation. And let's start by using f of x equals 3x minus 1, okay? All right, so that's something we've done in an earlier video. So to do f of 3, we would just plug in a 3 and work that out, and we would wind up with an 8, and that would be f of 3. And what I've got on here are 3 different functions. So we're going to start and do one that's just a linear function and see how that goes. And then we'll do the quadratic one, and then we'll do the rational one, okay? All right, so now f of negative 2 is going to feel pretty much the same. I just might make a mistake with it because of that negative number. So that's going to be negative 7. Okay, I'm going to see if I can write better if this is flat. Okay. All right, so now for f of a, I'm going to do a is my input, so I'm going to be plugging in a into my rule, which was 3 times my input minus 1. There's not much simplifying I can do. That's it, okay? Always feels like a trick question, but this would be your answer. You're just kind of creating a new formula in a way. All right? Now, these next two, let me turn this. Okay. All right. These next two kind of go together. I want you to really understand the difference between the next two. All right. Also for this, I think it helps for you to realize the rules that were given up here. Okay. The x is really almost just like a placeholder. Remember how f was supposed to be the process that was going on? So it's just really saying f of your input is just 3 times your input minus 1. So it's multiplying by 3 and taking away 1. All right, it's really important that you don't get the x that's up here, okay, mixed up with the x that's down here, okay? That's what can sometimes be a little hard at first. See, the input to the function is actually the whole entire x plus 1. All right, so let me see if I can widen this a little. Yeah. All right, so we're going to do f of x plus 1. It's going to require plugging in or using x plus 1 as my input and then subtracting 1. So that x plus 1, where's that pen? Goes right here. Okay. All right, so I wind up with f of x equaling 3x plus 3 minus 1. I have some like terms I can combine, and so I get this new rule, 3x plus 2. Okay. Now the difference between f of the quantity x plus 1, f of the x plus 1 inside the parentheses, and this one where I do f of x and then add 2 really has to do with this idea. Here, the x plus 1 is going into the machine. F acts on it, and you get something out that happens to be 3x plus 2. Okay. What's going on the next one is that only x goes in. F acts on that, and you get an f of x out, and then when you're finished, you take the f of x and add 2. You see that? The 2 never goes into the machine at the beginning. All right. All right, so let's go ahead and do this one. So this is more like expression I'm going to be plugging into. I know oops, that wasn't supposed to be, it was supposed to be a plus. I know f of x is 3x minus 1. That was the definition way at the top there. And then after the fact, I add 2. And so when I combine my like terms, I get 3x plus 1. Okay. Do you see the difference? I didn't put x plus 2 into the function machine. Here I close the parenthesis after the x. Okay. Now f of x plus h, it's more like f of x plus 1 than anything else. Okay. It's kind of like f of x plus 1. When I do f of x plus h, I'm going to do 3 times my input and then take away 1. When I distribute, I don't get any like terms that I can combine. This would be my final answer. Okay. All right, now, let me see if I can get to a new page. All right, I'm going to need a bigger box to show you this. All right, now the last thing we're doing is really important. And you should think of it like it's a formula that says do f of x plus h, get your f of x, divide all of that by h. Okay. So we're going to take the f of x plus h, and it goes here. We're going to get f of x and put it here. And then the formula says subtract those two things and divide by h. Okay. Well, we just worked out f of x plus h. That was this expression here. So this, what I'm doing, this last box is really a formula. You don't plug one thing into your function f. You evaluate these different pieces and put them into your function. So in place of the f of x plus h, I put 3x plus 3h minus 1. In place of f of x, I have to really look way back here. F of x was just 3x minus 1. But be careful, because this and this get subtracted, and when you're finished, you divide by h. Okay. All right, so let's see what we get. So there's an understood positive 1 here, an understood negative 1 there. So this would just be 3x plus 3h minus 1. But here, when you distribute, you see how you'll get negative 3x plus 1? And then all of that divided by h. So the x's cancel. Negative 1 and positive 1 would be 0. So I get 3h divided by h. And since that's 3 times h, I can actually say h divided by h would just be 1. And my final answer is 3. So all that work tells me this. Okay, that for that function, that expression I had you plug into would just be 3. Okay. All right, let's try this again, but let's try it with a different function. Okay. So I'm going to go back. And we're going to look at the quadratic function. F of x equals x squared minus 9. So if we're asked for f of 3, we just plug in the 3, take away 9. It's 9 minus 9, we get a 0. Plug in my charger, okay? All right, now f of negative 2, you have to be careful, because this rule right here says whatever your input is, you're going to square it. And see, when I wrote it on the first problem, I didn't put the parentheses right here because it didn't matter so much. See, 3 to the second or 3 in parentheses to the second, that's going to give you a 9. But really, I should have been thinking this. See, I got to be careful. If I write it negative 2 to the second like that and put it in my calculator, it will say negative 13. But that's not what the problem says. The problem says your input gets squared. So you have to have parentheses on that -2. And when you square a -2, that's +4, isn't it? You see that? And then 4 minus 9 would be -5. Okay. Okay. All right, now, f of a is not very interesting. We're just going to plug the a in where the x was. So you just get a squared minus 9. All right, now let's look at f of x plus 1. Okay, this is going to require a little more algebraic work. When you do f of x plus 1 here, x plus 1 is your input. So it has to be squared, and then you subtract 9. Okay, and when you square x plus 1 squared, don't make this mistake. Is not x squared plus 1. Some people think that. They just square each of those. That's just not true. This is really x plus 1 times itself. So we have x squared plus 1x plus 1x plus 1. We FOIL that out. Don't forget the minus 9. And so we wind up with an x squared plus 2x minus 8 once we combine like terms. Okay. All right, now f of x plus 2 is a formula, is an expression we're plugging into. In this column, f of x was defined to be x squared minus 9, and then we have to add 2. And so your answer in this column would be x squared minus 7. All right. All right. Now, f of x plus h, where you're using x plus h as your input. All right. It's kind of like, that's kind of like this one. It's just instead of x plus 1, you're doing x plus h. So you start off pretty much the same. And don't make the mistake of just doing x squared plus h squared. That's not true. Okay. So you're going to be thinking this is x plus h twice. And so you're going to come in and do x squared plus xh plus another xh plus h squared, and then take away 9. So that's x squared, and then you got 2xh plus h squared, and then take away 9. And then none of those are like terms, so that would be as good as it gets. Okay. All right, so sometimes you have a little more algebraic work to do, but it's still the same concept. Just depends on how the function was defined, how much work you're going to have. Okay, now that's going to be the case here. When I try to do the f of x plus h minus f of x over h, I do the same work that I did here. Okay, but I'm going to use the middle column now. All right, so here's the f of x plus h. That's what it simplified down to be. Okay. It was x squared, so I'm putting it right there, plus h squared minus 9. Okay, that was that part. Then I'm taking away f of x. You can go all the way up to the top, or you can just remember it was x squared minus 9. And then see how I had to subtract them and divide them by h. So this is the middle column. All right, so that's x squared plus 2xh plus h squared minus 9. And then that negative is in front of that. And so that's like a -1 that needs to be distributed. So you should be thinking minus x squared plus 9. A lot of people miss that plus 9. All right, now if you've done these correctly, okay, you should have a lot of stuff cancel like what you did over here when it was linear. All right, and look, the x squareds are gone, and the 9 and the negative 9 are gone. I always like to collect what I have at that point. Okay, so I have 2xh plus h squared divided by h. Okay. So this is a big fraction bar with the h underneath it, which means that h actually has to be distributed into both terms. That h needs to be knocked out of each of those. So do you see how that would be 2x plus h? That would be your final answer on that. Okay. All right, so a little bit more work up here when we had to do the x plus h squared, but basically the same idea as before with some of the same issues as before. Okay. This video is getting kind of long. I think I'm going to stop it and do the rational column in a separate video.